Alright, this is part one to the circles review sheet. Alright, let's get started. First of all, this is all about the vocabulary terms and pieces of the circle. Okay, so first I want to look at this. Number one is I shouldn't say it. It's a segment AB. If you look at this, the way the symbol is working, it's AB, so 2 points. But above it, it's a segment. There are no arrows on it. There's no nothing. So it's a segment AB. So if I just want to look at from A to B, I already started saying the answer. The answer is chord. So A, chord. I'm not going to write the whole thing. How about I just write the letter? This is a chord. Okay, the second one, if we notice, number two, AB has these little arrows on it. I know they're very small, but they are there, little arrows. So that means this is line AB. So we're going from through A and B. It's a line all the way through it. A line all the way through the circle where it intersects twice. It's called a secant line, so F. Number three, point C. Point C right here, well, it's on the edge of the circle. And this is interesting. Well, it could be E, point of tangency, but we would need to know that if this is a tangent line. So let's skip this for a second, actually. Um, yeah, I'm going to skip number three. I'm going to come back to it. So number four, point E. Point E. Well, this is in the middle of the circle. The middle we call the center, so D. Number five is segment AE, just like up number one, segment AE. Goes from E to A, or A to E, doesn't matter. This segment right here, from the center to the circle, is called the radius. Number six, again, the arrows are little tiny, but this is line CF. Line CF. This is a line that intersects the circle exactly one time. We call this a tangent line, J. And so if line CF is a tangent line because it intersects the circle exactly one time, and it intersects the circle at point C, that means that point C, where the tangent line intersects the circle, is called the point of tangency. So we're going to come up back to number three. We'll mark that the point of tangency E. Number seven is segment DE. So if it goes from the edge of the circle or on the circle to the center, or vice versa, the center to the edge of the circle, just like AE, this is also a radius. Number eight, arc AD. It curves up there on the top. So this is arc AD. From A to D. Well, it's not a very big arc. We also know that it's only two letters. If it's just two letters, it's a little arc. It's called a minor arc. Number nine, ACD. So from A around to C and then back up to D. So this is a lot of the circle. Not quite all of the circle, but quite a bit of the circle. ACD. It's going to be a major arc. And arc ABC. A to B to C. Well, it goes from one end to the other, and it cuts the circle in half exactly. That's called a semicircle, I. There was one that we actually did not use here, and that is B, diameter. So I want to talk about the diameter really quick since it wasn't there. The diameter is a chord, basically. It goes from one side of the circle to the other, and it always contains the center point. So in this case, the diameter is the segment AC. Okay. All right, next question. This is number 11. It says, use a picture provided to answer the following questions. It wants us to find the length of the arc WT. Length. Well, a lot of us remember how to find the measure of these arcs, and if we look at this right here, if we're looking at arc WT, I'm actually going to highlight this. Let's make it this color. Arc WT. Well, that wasn't good. Okay, there we go. So arc WT. Well, if this arc is what we're trying to find, and again, we're finding the length, there's an equation we got to use. Okay, so what's the equation for arc length? Well, the arc length is the degree measure, divided by 360. We multiply it by the circumference. So it's degree measure divided by 360 multiplied by the circumference. Okay, so we want to first know the degree measure of the arc WT, and again, most of us will remember how to do this because this angle right here, is a central angle, meaning the vertex is at the center, means the arc is exactly the same as the angle, so the arc is also 65 degrees. So that's our degree measure. I'm going to plug this in. Let's use it up here. So 65 divided by 360 multiplied by the circumference. What is circumference? Circumference is, again, all the way around the circle. It's the perimeter of the circle. And the equation for circumference is pi times diameter. Okay, well, what's the diameter? Well, I can see this segment right here. This is 7, and this is what we call a radius from the center of the circle to the edge of the circle. So if this is the radius is 7. That means the diameter is multiplied by 2, 14. So the circumference in this case is pi times diameter of 14. So 14 times pi, which is 14 pi. If we go and put this into the calculator, we get 65 divided by 360, and we multiply that by 14. I'm going to go ahead and leave in terms of pi, and we get 2.5 pi. Okay, number 12 is very, very similar. It says find the length of the arc RH. So let's use a different color. Let's use this pink color. So RH, that one right there. So if we're finding the length of the arc RH, again we use the arc length equation, which is degree measure divided by 360 multiplied by circumference. Although in this case we have slightly different numbers. So first, what is the degree measure of our arc? Well, if the central angle is 33 degrees, that means our arc is also 33 degrees. So our degree measure, 33 over 360 multiplied by our circumference. Well, what's our circumference? We already found that. Since the circle didn't change, the radius didn't change, the diameter didn't change, that means the circumference is the exact same as the one before, the question before, so it's also 14 pi. If we plug this in the calculator, 33 divided by 360 multiplied by 14, this is again, we'll leave it in terms of pi, 1.28 or 1.3 pi. This is questions numbers 11 and 12. We're going to use the exact same picture for questions 13 and 14. Okay, so on number 13 it says, what is M of arc OR? Well, what does the M stand for? The M stands for the measure. So the measure of arc OR. Well, let's look for it. Arc OR, we can highlight it. Let's use green. Let's try that again. Okay, so arc OR. If I want to find the measure of that, I can do it a couple different ways. The easiest way is, well, we look to see what's given to us, and we see the central angle is this little box thing, which means that it's 90 degrees. And if the central angle is 90 degrees, that means the intercepted arc is also 90 degrees. Okay, remember the central angle is always equal to or congruent to the measure of the intercepted arc. Okay, number 14, find the area of the sector bounded by, bounded by segment MH and the arc MTH. So let's go ahead and try this out. Highlighter, let's pick a different color. Actually let's just use yellow. I'm going to erase this on the picture. Okay, so we want it bound by MH, segment MH, so from M to H, you can't really see that. Let's go back to the green. From M to H, that segment right there. and the arc MTH. So M around to T, then down to H. So we want this sector. So I'm going to color it in. Okay, this sector. Okay. Remember, a sector is kind of like a piece of pizza where it's just part of the circle. Okay, so we want to find the area of this green piece. Well, in order to do that, we know that the area of a sector, there's an equation for it. It's degree measure divided by 360, kind of like the length of what we just did, but instead we're going to multiply by the area. So degree measure divided by 360 times the area. This is how you find the area of a sector. Okay, so the degree measure. Well, we know that M to H includes the center. It's a chord that includes the center, meaning it's a diameter. So that means the entire degree measure, it's half of a circle, which is 180 degrees. So we divide that by 360. Then we multiply by the area. The area, which is the area of the circle, is pi r squared. The radius of the circle we said was 7, just like before. We're going to square that. 7 squared is 49, and we keep our pi. That is the area of the circle. We can now plug this into the calculator and find an answer. So 180 divided by 360 multiplied by 49. Let's go ahead and keep in terms of pi. We end up with 24.5 pi. Next question. This is actually for 15, 16, and 17. It all uses this same picture. Okay, so first of all it says the measure of angle BAD. Measure of angle BAD. BAD is 58 degrees. The measure of arc BC, from B to C, is 48 degrees. And the arc from A to B, the measure of arc AB is 110. So this is all the given information for us. We want to use these things to find number 15, 16, and 17. Okay, so first what we're going to do is use this information. Let's just find everything that we can on the circle. First, I can see that there is a shape A, B, C, D. The shape on the inside, or what we call inscribed, in the circle. If we have a four-sided figure inscribed on the inside of that circle, that means a couple things. First of all, we know that opposite angles, for example, angle A and angle C, or angle B and angle D, opposite angles are always supplementary. Supplementary means adds up to 180. So we can find angle C by A and C being supplementary. If we know what A is, we can subtract out A, which is 58 degrees, from 180, and that'll give us angle C. So 180 minus 58 is 122, and that's what angle C is, 122 degrees. Okay, so what else can we find? Well, I also know that angle BAD, this angle right here, has its vertex, A, on the circle. If the vertex is on the circle, it's called an inscribed angle. And an inscribed angle is always half of the intercepted arc. So if I know the angle is 58 degrees, I'm going to go backwards. Instead of it being half the arc, I'm going to multiply it by 2, so 58 times 2, which gives me 116 degrees, and that's what's going to be the intercepted arc. And if we look at this, A goes to B, and A goes to D for this angle right here. Meaning the intercepted arc is this whole piece right here. And that's what's going to be 116 degrees. Okay, my drawing's not the best, but hey. Okay, so the arc BD is 116 degrees. Well, that can help to find the arc CD. Because if I know BD is 116, I know BC is only 48. I know something has to add together with 48 to make 116. So I can say 116 minus 48. I end up with 68 degrees. Okay. Well, if I know three of these arcs, these pieces, arc AB, arc BC, and arc CD, the only one I'm missing is arc AD, this one right here. I also know that a full circle is 100 and, no it's not, it's 360 degrees. Full circle is 360 degrees. I can just add these three pieces up that I already know, subtract it from 360, and that'll find arc AD. So let's go ahead and do that. So first, I'll go ahead and do it down here. So 110 plus 48 plus 68. Add all these up. So 110 plus 48 plus 68. It gives us 226. And we can say 360 minus 226. And that gives us 134. And that's what this arc has to be AD. We can check our work by saying 134 plus 110 plus 48 plus 68, all four of those, which is the whole circle, has to give us 360. Okay, so now we have that one, and I'm going to find this angle right here. Now, how do I find that angle? Well, first let's name that angle. It's angle ADC, or angle CDA, this angle. And how do we find that? Well, we can find this angle by one easy way, or one easier way. So we can also notice, I'll go ahead and try to highlight this. Let's use this blue. The angle, it goes from A to D, and from D to C. Okay, so this angle right here, which gives us the arc A, B, C as the intercepted arc. A, B, C is the intercepted arc. And we know that if we have an intercepted arc, the inscribed angle is half the intercepted arc, just like what we did before with 58 and 116. Now we're going to go back the normal way, so the arc divided by 2, which gives me the angle. If the whole arc ABC, well I don't know it yet, but I can find it because I know AB is 110, BC is 48, I can add those together, which is, I'll put on my little plus sign, 158 degrees. And we can divide 158 by 2 to get 79 degrees for our angle CDA. That is right here, so measure of angle CDA is 79 degrees. Again, it came from right here. I do know the measure of arc CD, we found it to be 68 degrees. And we found the measure of arc BAD, or we didn't actually find it yet, but we can. By knowing the arc BA and knowing the arc AD, we can just add these two numbers together. So let's go ahead and do that. 110 plus 134 gives us 145. Okay, the next question, it says line AB is tangent to circle C at point B. If it says it's tangent at point B, that means point B is called the point of tangency. If it's a point of tangency, it tells us a couple things. First of all, if you draw a line from the center of the circle to the point of tangency, it would be called a radius, and that radius is always going to be perpendicular, or makes a 90-degree angle with our tangent line. That's the biggest thing it tells us right there. We know a couple other things. First of all, AB is 25 and CB is 15, so let's plug those things in. AB 25 and CB 15. It says, what is segment AC? So we want to find this one. Well, what shape do we have now? We now have a right triangle. If it's a right triangle, and I know two of the sides, we can find it by Pythagorean Theorem. So we can say 25 squared plus 15 squared is equal to x squared. 25 squared is 625. 15 squared is 225. let's make this plus sign a little bit better. Equal to x squared. Add these two numbers together. 625 plus 225 is 850. How do you get rid of the squared? You do the opposite, which is square root, so we get x is equal to the square root of 850. And if you put that in the calculator, you'll end up with a crazy decimal, but we'll go ahead and round to the tenths place, which is 29.2. And that's what x is. Again, how do we do this? If it's tangent, if AB is a tangent line, that means that it has to be a right angle. If it's a right angle, we now have a right triangle. I know two of the sides of the right triangle. I can find the third by Pythagorean Theorem. Number 19 is very, very similar to it. It says if AC is 49 and AB is 22, what's BC? Okay, again, AB is tangent to circle C, so meaning this is a right angle. And if CB is what we're calling X, well, what is the segment CB called? It connects the center to the edge of the circle. It's actually the radius. So how do we find the radius here? Well, again, we have a right triangle, so we can do Pythagorean theorem. It looks a little bit different from last time just because we know the hypotenuse and we don't know one of the legs. So it's going to look 22. Oh, it's not 22, that's 2x. 22 squared plus x squared, because it's our leg, is equal to 49 squared, and that's our hypotenuse. Okay, there's going to be some big numbers, but 22 squared is 484 plus x squared is equal to 49 squared, which is 2,401. We can find x by getting rid of this 484, so subtract 484 on both sides. So 2,401 minus 484 is 1917. To get rid of the squared, we take a square root. So x is equal to square root of 1917. And square root of 1917 is 43.8 if we round to the tenths place. Okay, so we said, again, Pythagorean theorem because it makes a right triangle, because it's a tangent line. We're going to find the radius, segment BC, by doing Pythagorean theorem. So 22 squared plus x squared equals 49 squared. We can subtract, you end up with x squared is equal to 1917, great year. And then we take the square root, and we find 43.8. Okay, this next one, number 20, it says if AB is equal to 36, AC is equal to 89, and angle, the measure of angle ACB is 42. Find the length of arc DB. If I'm not mistaken, on the piece of paper that you were given, it just says find the length. We actually want to find the length of arc DB. So I'm going to go ahead and highlight that arc first. We can go ahead and use this. Let's use this pink color. So arc DB. I don't know why it did that. There we go. Okay, so this is the arc we want to find, and we want to find the length of that arc, length. So if we remember, we can find the length of an arc by doing degree measure, divide by 360, and we multiply by the circumference, just like what we did earlier on in the review sheet. Before we can do all that, though, we need to be able to find the degree measure. We need to know what the circumference is. And right now we don't know anything. So let's first write down what we do know. So it says if AB is 36, AB is 36, AC is 89, and the measure of angle ACB is 42, can we find the length of arc DB? So again, we want to fill out this equation. So first of all, degree measure. How do we find the degree measure? Well, if we look, 42 degrees, angle ACB, is a central angle. The central angle, we remember, is always equal to the intercepted arc. So this arc, DB, which we're trying to find the length of, is going to be the same measure as the central angle, which is 42. So we can start filling this out. So we get 42 as our degree measure, divided by 360, multiplied by Circumference. Well, great. Circumference. Remember, circumference is equal to pi times diameter, but we don't know the diameter. We don't even know the radius. So can we find those pieces? Sure we can. Again, since this is a tangent line, that means that it makes a right angle with the tangent line and the radius at the point of tangency, point B. So now we have a right angle. We know two sides of the right triangle. We can find the third by, you guessed it, Pythagorean Theorem. So we can say 36 squared plus x squared is equal to 89 squared. We're going to have some super fun numbers. I wanted to rewrite that. Okay, so 36 squared is 1,296 plus x squared is equal to 89 squared is going to be ridiculous, 7,921. We can subtract these to get x squared by itself. So 7,921 minus 1,296, excuse me, we get 6,625. Yippee. To get rid of the squared, we take the square root. So x is equal to square root of 6,625. So the square root of this crazy number is 81 point, let's go ahead and round it to tenths, 4. So that's going to be our radius right here, 81.4. So yay, we know the radius. So what does that mean the diameter is? Well, if the radius is 81.4, all you have to do is multiply it by 2. So radius is equal to 81.4. Multiplied by 2, you get the diameter to be, yay, decimals, am I right? We get 162.8. Okay, so that's going to be our diameter. So let's just plug this in to find circumference. Pi times 162.8. Well, it's 162.8 times pi. Let's go ahead and leave it in terms of pi. We get 162.8 pi. We can multiply these together by first dividing 42 divided by 360. Then you multiply it by 162.8. Let's go ahead and leave this in terms of pi. We get a crazy awesome answer. 19.0, or it's actually 18.99, but we'll leave it as rounded to tenths, so 19.0. So we get 19 pi, and this is the arc length, or the length of the arc DB. Okay, this is it for part 1 of the review sheet. If you want to watch part 2, go for it. Good luck.